Relative risk and odds ratio for 2 by 2 contingency tables. Note, a 2 by 2 table is a two-way table where each categorical variable takes only two categories. Example of a 2 by 2 contingency table. So you have on the rows section, you have yes and no. For the question, first child at age 25 or older, and in the columns variable, you have breast cancer or no breast cancer. And you have the totals also filled in. Risk, probability, and odds. A population contains 1,000 individuals, of which 400 carry the gene for a disease. Equivalent ways to express this proportion: 40% of all individuals carry the gene. The proportion who carry the gene is 0.40. The probability that someone carries the gene is 0.40. The risk of carrying the gene is 0.40. The odds of carrying the gene are 4 to 6, or 2 to 3, or 2 out of 3 to 1. Percentage with trait equals number with trait divided by the total, all times 100%. Proportion with trait equals number with trait divided by the total. Probability of having trait equals number with trait divided by the total. Risk of having trait equals number with trait divided by the total. Odds of having trait equals number with trait divided by number without trait to 1. Baseline risk and relative risk. Baseline risk, risk without treatment or behavior, can be difficult to find. If placebo is included, the baseline risk equals the risk for the placebo group. Relative risk of outcome for two categories of explanatory variable is ratio of risks for each category. Relative risk of 3. Risk of developing disease for one group is 3 times what it is for another group. Relative risk of 1. Risk is the same for both categories of the explanatory variable or both groups. Example, relative risk of developing breast cancer. Okay, so we're looking back at the 2 by 2 contingency table for breast cancer variable and the variable of first child at age 25 or older. Yes, no. Okay, so the risk for women having their first child at 25 or older is 31 divided by 1,628 equals 0.0190. Risk for women having first child before 25 equals 65 divided by 4,540 equals 0.0143. Relative risk equals 0.0190 divided by 0.0143 equals 1.33. Risk of developing breast cancer is 1.33 times greater for women who had their first child at 25 or older. Okay, so risk for women having first child at 25 or older is 31 divided by 1,628. So you look at people who had a child at 25 or older and who did get breast cancer. So that value in the cell is 31. And then you divide it by 1,628, which is the total number of people who had their first child at age 25 or older. And the risk for women having first child before 25 is 65 divided by 4,520. So you look at the rows variable of first child at age 25 or older, and you look at no, because they had their first child before the age of 25, and then you look at the people who did have breast cancer, and the total in that cell is 65, and then you divide it by the total number of people who were under 25 when they had breast cancer, which is 4,540. And then to calculate the relative risk, you take 0.0190 divided by 0.0143. So 0.0190 is the risk for women who had their first child at 25 or older, and you divide it by the risk of women who had their first child before 25 to get 1.33. So the risk of developing breast cancer, you can conclude, is 1.33 times greater for women who had their first child at 25 or older. Odds ratio. Ratio of the odds of getting the disease to the odds of not getting the disease. Example, odds ratio for breast cancer. Odds for women having the first child at 25 or older is 31 divided by 1,597 equals 0.0194. Odds for women having the first child before age 25 equals 65 divided by 4,475 equals 0.0145. Odds ratio equals 0.0194 divided by 0.0145 equals 1.34. Alternative formula, odds ratio equals, in the numerator, 31 times 4,475 divided by the denominator of 1,597 times 65 equals 1.34. Okay, so for this odds example, we are still looking at the same 2x2 contingency table. So when we look at the odds for women having the first child at age 25 or older in terms of having breast cancer, the calculation is 31 divided by 1,597. So 31 is the number of people who had a first child at age 25 or older, answered yes, and who had breast cancer. And then you divide this by the number of women who had a child at age 25 or older but didn't have breast cancer. So 1,597. Odds for women having their first child before age 25 and getting breast cancer. So you take the women who answered no to first child at age 25 or older and who did have breast cancer, which is 65, the value in that cell, and then you divide it by the number of people who answered no to having their first child at age 25 or older and no to breast cancer, which is 4,475. And then the odds ratio is the odds of the first one of women having the first child at age 25 or older and having breast cancer divided by the odds of the second one, the odds of women having their first child before age 25 and having breast cancer, and that equals 1.34. So when you look at the alternative formula for the odds ratio, what you're doing in the numerator is you're multiplying 31 by 4,475. So 31 is the number of women who responded yes, they had their first child at age 25 or older and they had breast cancer, and 4,475 is the number of people who said no to having a child at age 25 or older and no to breast cancer. And then in the denominator, you're multiplying 1,597, which is the number of people who answered yes to having their first child at age 25 or older and no to breast cancer, by the number of women who said no to having their first child at age 25 or older and said that they did have breast cancer, which will give you 1.34 again. For those who like formulas, to represent the observed numbers in a 2x2 contingency table, we use the notation. Okay, if you answered yes on both variables, it's A. If you answered yes on variable 1 and no on variable 2, it's B, and the total is A plus B. If you answered no on variable 1 and yes on variable 2, it's C. If you answered no on variable 1 and no on variable 2, it's D, and the total is C plus D. And for the totals roll, the total of yes is A plus C, and the total of no is B plus D, and the sum total is N of all the observations. Relative risk and odds ratio. Using the notation for the observed numbers, if variable 1 is the explanatory variable and variable 2 is the response variable, then we can compute relative risk is equal to A times, in brackets, C plus D in the numerator divided by C times, in the denominator, A plus B. And the odds ratio in the numerator is A times D divided by, in the denominator, B times C.